let's go ahead and get started. Couple things. I have tests for you, so if you want yours back, stick around after class. I'll make sure you get it. Also, I mean, we're not too far away, so I want to let you know the next test is on the 20th of March, which a little closer than it seems. There's a spring break in the middle there, but that's coming up not too terribly far away. Looks like my screen's frozen again. So getting back into, so we just started section 7.4 last time, which is about arc length. So basically how to find the length of a curve over some interval using Riemann integrals. Yeah, we'll, as soon as my screen starts talking to me again, we'll get back into it. Cool. So I think the very last thing we did on Friday was to develop these, basically these integrals right here at the bottom. And the only real difference between them is what variable you're working with. Are you going to integrate in terms of x, or are you going to integrate in terms of y? But other than that, these integrals are identical. They're both based on this, Pythagorean theorem, algebra manipulation we did last time. So see a few examples of this.
You just square the derivative, right? The derivative function, not the 1 plus.
No, the derivative is the only thing that's squared. Yeah, dy dx is squared. So I want to find the arc length of this curve over this interval. So first time out, I'll try to draw a graph of this, but it'll be very approximate. So from x equals 1 to x equals 4, do I know y values? So it should begin at 1, 1, and where should it go? What is 4 to the 3 halves? 8. So, and this will be a concave up function, so something like that, roughly speaking. So I want to find the exact length of this curve over this interval. So if I'm trying to find arc length, it's the integral from a to b. I don't know if this is exactly the way that it looked on the last page, but it's equivalent. So basically, this is the integral we're going to set up. So let's think about what things we need to do to make this integral specific to what we're trying to do. So what can we figure out first? Get the derivative. All right, so I know that y is equal to x to the 3 halves. What does that mean about dy dx? Three halves times x to the 1 half. Good. We do need that. What else? What's that? So yeah, let's go ahead and square it while we're at it. What is this thing squared? What's that? 9/4 times x. There's one thing we haven't explicitly said that we need to. What are the bounds here? 1 to 4. So in this case, I gave them to you. So the integral from 1 to 4 of 1 plus 9/4 x dx. Is that an integral we can do? I don't know if we can do it directly, so we probably need to do some kind of manipulation to it. How can we make this a little more digestible? We can do u substitution. What's a good u? Okay, how'd you get that?
Because if we take its derivative, we'll just be left with a constant
Okay, so that's why this will work. But I think this kind of goes back to one of the very first things I think we talked about, which is when you're doing U substitution, one of the first things that's usually wise to look for is that inner function. So what's under the radical is a good place to start here. And like Caleb said, I think this will work because of what du is. What is du going to be? 9/4 dx. So that should allow us to turn this integral into what? Yeah, let's go ahead and solve for dx as well. Dx equals 4/9 du. I'll leave the bounds alone for now. So this becomes the square root of u, and dx becomes 4/9 du. We know what the bound should be. Or more importantly, can we find them out? So we know that u equals 1 plus 9/4 x. So if you plug in 1 and 4, we should be able to get some new bounds. So I think the upper bound is a little easier to get. That should be 10. What should the lower bound be? 13/4. So again, that comes from 1 plus 9/4 times 1 and 1 plus 9/4 times 4. So 13/4 and 10. And the new integral is 4/9, which I'm pulling to the outside, times the square root of u du. So integral looks totally different. Are we okay with how we got here after the substitution? All right, now what? What is the integral of u to the 1/2? Two-thirds u to the 3/2 evaluated at 10 and 13/4. Then you cancel for me here. So I get 8/27 times u to the 3/2 on these bounds. I don't think these are going to come out very conveniently. So let's go. Let's get an approximation here. So 8/27 times 10 to the 3/2 minus 8/27 times 13/4 to the 3/2. We get an approximation for what that looks like, or for how much that is. So this is about 1.599. I must have done something wrong, because that doesn't make any sense. If someone else approximates this, let me know what the right answer is, because that can't be. $7.63. That seems to make more sense. Any questions here? Are we doing okay? All right. So let's go again. How about this thing? How would you like to start? Try to find our derivative. Can we find a derivative of natural log of cosine of x? Chain rule. So y prime is equal to what? How'd you get there?
Cosine of x equals u.
Okay.
Natural log of u is
So yeah, we're doing, we got to do chain rule here. We have a function nested inside another function. What's the outer function here? What's the derivative of natural log? 1 over x, except our inside function is not x, it's cosine of x, times the derivative of cosine of x, which is negative sine of x, which is what? All told, I think the simplest we can say it is negative tangent x. Okay. Yep, we definitely need that. Now what can we do with that? Okay, so our bounds are given to us again. So integrating from 0 to pi over 4 of the square root of 1 plus minus tangent x squared dx. Is this an integral we can do?
Substitute for secant x.
That's equal to secant squared x? Okay. And if I recall, the integral of secant x is this thing here. Which I'm happy at this stage if we're just Googling, but yeah, this is the integral of secant x. So we've kind of gone a long way pretty quickly. So let's pause. Go ahead.
Why is it, 1 plus tan squared if it's negative?
Because we're squaring this right here. So the negative is going to get canceled out. What else? Or are we good to evaluate? So I got the natural log of what is the secant of pi over 4? Well, we can do it exactly, can't we? What's the cosine of pi over 4? Square root of 2 over 2. So I believe the secant of that's equal to 2 over radical 2, right? Which is equal to radical 2. So I should get the natural log of radical 2. What's the tangent of pi over 4? That's a little more palatable. Minus the natural log of secant of 0 is 1, right? And tangent of 0 is 0. So I think all told we get the natural log of 1 plus radical 2. How we doing? So a few things have popped up here. Properties of, the Pythagorean identities are still there if they make sense for us to use them. The reciprocal trig functions, make sure we know how they work and relate to things that are probably more familiar to us. Any questions before we go on? All right. All right. So I got a beginning point, I got an ending point. I have a curve. How should we start?
F of X.
So we can identify f of x. Yeah, in this case, we don't have a function kind of in either of the two forms that might be good for us. So what is f of x in this case? Should be 1 over x. Cool. Yeah, we do need that. Now what can we do with that? Yeah, can't integrate 1 over x. I mean, the integral is going to involve 1 over x, but I got to do something. Really, we need this derivative, right? Which is what? -1 over x squared. So now I think we can set up the integral from where to where? 1 to 2 in this case. And we're integrating what? Square root of what? Is this an integral we can do? Maybe, maybe not. So let's pause here for a second before we talk strategy. Are we okay with how we got this integral? Go ahead.
Sorry, why did we do that?
Good question. Yeah, where'd this come from right here? X times y equals 1. So
Okay.
yeah, so in order for us to go forward, that was not something we had to do. We kind of had a choice. We could have done, y equals 1 over x is probably the more familiar, comfortable way to go. But we also could have done x equals 1 over y and found that x prime equals -1 over y squared.
So does it really matter like which one?
Not really. The only difference I really want to point out is what's the integral that comes out of this? It's going to be something, yeah, the integral of 1 plus negative 1 over y squared dy. What are the bounds going to be? 1/2 to 1. So if you decide to go that other way, basically you end up with other than me renaming that variable, this integral is identical to the one we're dealing with. But it's the bounds you have to be really careful about. All right. This integral does not look like something we can use substitution to kind of get ourselves clear of it. But let's try this. Let's try to add the 1 plus 1 over x to the 4th. So if I want to add those together and collect them under a single fraction, how can I do that? So yeah, get a common denominator, which should be x to the fourth. So I can rewrite this as x to the fourth plus 1 over x to the fourth. Did that do anything for me? Can I do this now? So that is legal. I don't know if it did me any good. Does anyone see a way forward with this integral? Go ahead.
Do you have to change to like trig, so like sine to cosine?
The only thing that makes me suspicious about that is that I don't have, like, underneath the radical, I have x to the fourth. So I'm not sure how to get there. So one thing I want to point out about these arc length integrals is, and it's a pretty common occurrence, is that the integral you wind up with could be something that is either very difficult to do by hand, or you might not have the tools to do by hand. So I don't know if I already posted it, and maybe I haven't, but the written homework for this and a lot of the things that are going to show up on the web work, set up the integral, but if you run into like serious trouble, just go to a calculator. Because a lot of these integrals that come out of this, they are under, I mean, not that any of them are friendly, but these are under even less obligation to come out in convenient ways for you. So yeah, setting up the integral is definitely a burden I'll put on you, but some of these cannot be done either easily or at all using like manual techniques that we've gone over. And unless I'm missing something, I think this is one of those times. I mean, I think even if this was 1 over x cubed, I could probably do something, but I don't even see how, like, I don't see substitution helping me. I don't think I can factor x to the fourth plus 1, can I? Pretty sure you can. So I think for this one, we'll stay with the setup. Any questions here? Go ahead.
So like in a case like this, would you put it like into like an interval factor or something to get a number, or like would that be fine?
Depends on what I ask you for.
Okay.
Like if I ask you for an approximation, the fact that this has bounds, like your TI calculator could give you a number here,
Okay.
or anything on the internet could give you. I mean, really, if I wanted to do an indefinite integral with this, like Symbolab or Wolfram or whatever else could probably do it. But typically with arc length, you're not doing things with indefinite bounds. Good question.
Would they give us what's it called, the table of integrals for this, and possibly this would be
I may, yeah.
on the table?
Yeah, but like for the purposes of homework and stuff, yeah, you have the internet and the book and whatever else you want to go search through. But yeah, if we're gonna have you use one of those like really obscure tables, we'll give you the one you need. What else here? All right. Let's go again. Oh, sorry. All right, what would you like to do? Let's get a derivative. What is it?
Squared. Minus 1/4 squared.
Minus 1 over 4x squared.
I think so.
How do we feel about that? Okay, if there are no protests, it seems okay to me. So that's a good derivative. Now what? Okay, do we know the bounds? 1 and 2. Integrating what? 1 plus this thing squared. Is this an integral we can do? No idea. Let's think about it. What do I get if I expand this bracket in here? I should get x to the 4th. Minus a half. Two times x squared times negative 1 over 4x squared. I think all the x's cancel. And the last thing I get is what? Plus 1/16. 1 over 16x squared. X to the 4th? Never mind. X to the 4th. Is this an integral we can do? I don't think I'm convinced yet either way. So let's simplify one more time. So I get x to the 4th plus 1 over 16x to the 4th plus a half. Can we try to pull some things out of the square root like we tried last time? Can I add all these things together to get a common denominator? Let's try it. What's a common denominator I can build out of these three things? 16x to the 4th. So I think this first term is going to become 16x to the 8th. This one didn't alter. Plus 1. Plus what? 8x to the 4th. All over 16x to the 4th dx. Can I take a square root of 16x to the 4th? Should be able to. 1 over 4x squared times this square root. 16x to the 8th plus 8x to the 4th plus 1. Did that help? So let's look at what's under the radical. Can we factor what's under the radical there?
X to the 4th plus 1.
4x to the 4th plus 1. That's one factor. What's the other?
4x to the 4th plus 1.
So it's a perfect square, you're saying?
Yeah.
Well, that's convenient. Or maybe it's not convenient. So it's 4x to the 4th plus 1 squared dx. Do we believe that first of all? How did you get that? How did you factor that?
I just thought about 4 times 4 would equal 16. And x times x to the 4th times x to the 4th would be x to the 8th. And then I added 4x to the 4th to 4x to the 4th to see if I get 8x to the 4th.
Okay, so sounds like a little bit of intuition. In general, when we have things like, you know, this is not technically a quadratic, but you can kind of treat it like one. But typically what you're trying to do when you factor is, if you can find numbers that multiply together to give you a times c and add together to give you this b, that's typically what you look for your factor. You can kind of look for the same thing here. Are there numbers that I can multiply together to give me 16? Yeah, plenty of pairs of those, right? But which ones are going to add together to get you positive 8? I think 4 and 4 are the only pair that meets that So now from here, how does this simplify? Does this help? How?
The integral of, so you can put it over 4x squared, and then you can do 4x to the fourth over 4x squared plus 1 over 4x squared. and
What is 4x to the fourth over 4x squared?
x squared.
X squared. And then the other one is just going to be. Is this an integral I can actually do? Somehow, out of all that came something I can actually do manually. What's the integral of x squared? 1/3 x cubed. And 1 over 4x squared. -1 over 4x. Evaluated from 1 to 2. So yeah, some of these like they look very much like they're not going to work, but with a little bit of common denominator, not a little, I should say a little bit. There's a lot of algebra that got us to the end here, but starting with finding the common denominator of all the fractions you have to deal with, or all the terms you have to deal with, sometimes that lets you get rid of that square root. So 8/3 minus 1 over 8 minus so whatever this comes out to be. (59/24). So this is 64/24 minus, so 61. Yeah, I agree with you. So we went a long way on this. I mean, I think we set up the integral very quickly, but from the setup to even from setting up the integral, which I think happened here, to computing the integral, that happened 7 steps later. Now, there was a lot of algebra that went into turning this integral from something like from its original form into something we could actually take an antiderivative of. So that's one of the things to watch out for with these arc length integrals, is sometimes that those manipulations get pretty long-winded. So unless you're asked for something exactly, my feelings aren't going to be hurt if you lean on calculators to get those numbers. But then again, I wouldn't be surprised if you plug this into Symbolab or something, it didn't come up with this exact number. Maybe it'll be an approximation that won't round correctly. Any questions here? All right, let's go again. What should we do?
Derivative again.
You want to find derivative as is?
Yeah, will give us the balance in terms of y.
Okay. So I mean, there's a lot of good reason here to just leave this in terms of y. I gave you a function x in terms of y. I gave you y bounds. So we might as well just, instead of finding dy dx, yeah, let's try to find dx dy. How do we find derivatives like this?
Could do the product rule, or you could just distribute.
Yeah, I think product rule, yeah, would work, but I think I'm gonna try to get away with not doing it. So if I distribute, I get 1/3 times y to the 3/2 minus y to the 1/2. So what's that derivative in terms of y? One half y to the 1/2.
Minus 1 over 2 y to the 1/2.
Oh, why should I do that? Okay, I think that's what you said. All right, so got a derivative. What can I do with that? Okay, so integral from where to where? 1 to 9 of what?
Square root of 1 plus 1/2 y to the 1/2 minus 1 over 2y to the 1/2 all squared.
Okay, how are we doing with where we ended up? All right, what now? Yeah, so let's go ahead and distribute that, see what happens, if anything. So 1/4 y minus 1/2. Plus 1 over 4y. Is anything convenient going to happen for me? All right, I think we're okay. So let's pause. Any questions about how we set this up, where we ended up? What can we try now? Yeah, maybe it'll help. We don't know. What's the common denominator going to be here? 4y. So all over 4y. I believe this becomes y squared. That's just 1, right? Plus 2y. Did that help?
You 1 over 2 square root of y.
Okay, so yeah, I see that. So the 4y in the denominator, I could pull that out as 1 over 2 radical y. What happens to that quadratic in the numerator?
Y squared plus 2y plus 1.
So for now, I'll write y squared plus 2y plus 1. Oh, so this is still
Yeah,
square rooted, right?
you can factor it though, and take this.
Right, so that is a perfect square, which again really helps me get rid of that square root. Y squared plus 2y plus 1 is the same thing as y plus 1 squared. So I believe my integral ends up looking like this. Is this an integral we can do? Integration by parts? No, I don't think so. I don't think we need to. So that's one thing I wanted to keep highlighting is if you can get away from those like product rule, quotient rule, chain rule type things by making some simplifications, it's usually a good move. So we can simplify this into what? Radical y over 2 plus 1 over 2 radical y dy. And I think before I integrate, I might also like to look at these as powers instead of roots. So 1/2 y to the 1/2 plus 1/2 y to the negative 1/2. Questions? What is the antiderivative of 1/2 y to the 1/2? Yeah, I think ultimately will be. So 1/2 times 2/3 y to the 3/2 plus 1/2 times 2 y to the positive 1/2. So a few more favors that happen for us. So 1/3 y to the 3/2 plus y to the 1/2 from 1 to 9 gives us 1/3 times what? 9 to the 3/2 is 27. Plus 3 minus 9 plus 3 is 12, minus 1 is 11, minus 1/3 is 10 2/3. So 10 2/3 or 32 over 3. How are we doing? Questions? Complaints? I got one more for you. It's a little bit different, but let's do something that has a little bit of a indefinite component to it. So I don't want to find the arc length between a starting point and some other ending point. I want to find a function that gives you the arc length basically along this function. So let's organize it just a little bit. I don't have a very good idea at all what this function looks like, but that's okay. So I know I want to start it at the point 1, 1. And I want it to, basically I want to measure its arc length. Basically I want to let the right end of this arc be variable. So basically I'm trying to build a function instead of giving you a finite fixed constant number. But the common thing, same common goal here, I want arc length. So how do we do that?
We just have to wait to find balance, we just have to get the balance of X.
Yeah, so the bounds are gonna be, so that, yeah, we can kind of fill in the skeleton or write out the skeleton of this thing. The length, in fact, I'll call it length as a function of X, is an integral from where to where?
One day.
It's an integral from 1 to mystery variable X. Of what?
There's a bit of Y, so 2x minus 1 over 8x. Square root of that. 1 plus 1.
Okay, so
Square
let's-
that mess, yeah.
So yeah, we got a little more ways to go, but yeah, the template of this is largely gonna be the same. 1 plus y prime squared dx. So what is our y prime in this case?
2x minus 1 over 8x.
2x minus 1 over 8x. So now from there, where do I go?
Into the Y.
So integral looks a little different because it does not have a fixed upper bound, but do we see the similarities here between this and the previous things we did? Any questions on how we got here? All right, so let's see if we can simplify it a little bit. So if I square that, I get what? 1 plus 4x squared minus a half plus 1 over 64 squared. Can I get a common denominator out of these terms? What would it be? 64x squared? What's 64 times 4? 256 x to the 4th plus 1 plus 32x squared over 64x squared. Is that going to do anything convenient for us? It will. It will. So that denominator ends up becoming 1 over 8x. And this becomes the square root of 16x squared plus 1 squared. So we've seen a few cases now where it takes quite a bit of work to get there, but these do simplify in kind of a convenient way. I'm actually going to leave this the integration because I totally ran out of room. But this should be the integral from 1 to x of what? 2x plus 1 over 8x dx, which is an integral I believe strongly you could all do. Questions here? All right, so that's all I have for you from arc length. So we'll go ahead and stop here. We'll start a new section next time. If you want your test back, another reminder, stick around and I'll get it for you. Otherwise, I'll see you Wednesday.